When you build a suspension bridge, you don't just uh, stand at the edge of the water and whisper encouraging words to a pile of steel cables.
Right. You definitely don't.
I mean, you don't try to find the perfect magical sequence of adjectives to convince the concrete to somehow hold up 1,000 cars. You use physics.
Exactly. You use rigorous blueprints, tension limits, load distribution modeling. You use deep architectural primitives.
Yes. And yet, for the last 2 years, the entire corporate tech world has basically been standing at the edge of the river, whispering, please, to a pile of cables, just hoping an AI will magically build the bridge for them.
And, well, the reality of that approach is finally hitting them incredibly hard.
Oh, I bet it is.
Because the minute a real-world storm hits, or, the case of software, the minute real-world production data hits that bridge built on whispers goes straight into the river.
Just completely collapses.
Total collapse.
Yep.
The era of the prompt engineer is entirely over. The market has completely moved on to deep system architecture.
I cannot tell you how validating it is to hear you say that out loud,
Yeah.
because I spend my days as a venture catalyst. I look at pitches, I talk to technical founders, I write the checks.
So you see the absolute worst of it, I'm guessing?
Oh, I see it all. And frankly, I am entirely exhausted by corporate AI fluff. I am so tired of sitting across from a founding team and looking at a slide deck where their entire defensible business strategy is just a slightly better set of English instructions typed into a chat window.
Yeah, which is completely hollow.
It's totally hollow. But I am intensely enthusiastic about finding the real mechanics of value. That is exactly why we are at this table today.
Glad to be here.
Because you are the systems software architect. You actually build the infrastructure. You see right through the venture hype, and you understand the deep software primitives required to make these models work at scale.
Yeah, because my world is all about stability. It's predictability and resilience. A language model, if you strip it down, is just a raw combustion engine.
Okay, I like that analogy.
Right. It is a block of metal generating force. It doesn't become a vehicle until you build the transmission, the steering column, the brake lines, and, the safety chassis around it.
Right.
And what's happening right now is that the pioneers in the field are quietly learning how to build the transmission, while the vast majority of the industry is still just revving the raw engine in the driveway, wondering why they aren't getting anywhere.
Which is incredibly dangerous for a business.
Yeah.
So if you are sitting in a boardroom right now, or if you are staring at an IDE writing code, or even if you are an executive just trying to figure out why your company's highly funded, highly anticipated AI project is currently failing to launch, you need to hear this.
Absolutely.
We are completely ripping apart the illusion that magic words and prompt hacking are a viable corporate AI strategy. We have an incredible source document today. It's an insider curriculum overview that has quietly become the gold standard for real engineering.
Yeah, it's basically the blueprint.
The exact secret architectural blueprint that actual systems software engineers are using to build resilient enterprise-scale AI. So, okay, let's unpack this.
Let's start with the brutal reality of the current AI market and just bury this hype once and for all. Because for the past 2 years, AI education and really the entire corporate mindset has been hyper-focused on prompting.
Oh, yeah. Writing better instructions, chaining prompts together.
Telling the AI to think step by step.
Right.
What's fascinating here is that Anthropic's curriculum makes it brutally, unapologetically clear that these skills are completely insufficient for enterprise software development.
I have to admit, I actively mock the myth of the prompt engineer in my meetings.
I don't blame you at all.
I mean, the idea that a Fortune 500 company's core strategic advantage was going to be someone who figured out that if you tell the AI take a deep breath or I will tip you $20, it suddenly performs better. It's absurd.
It's literally a parlor trick.
Exactly. I have sat in boardrooms where highly paid people seriously debated whether adding the word please to a prompt improved the algorithmic output. It is corporate strategy reduced to finding the perfect combination of adjectives.
It stems from a massive, fundamental misunderstanding of what a language model actually is. And more importantly, how humans interact with new computing paradigms.
How do you mean?
Think about the history of computing. Every time a new paradigm emerges, the initial interaction layer is highly manual and localized. When we first got command line interfaces, people memorized hyper-specific syntax.
Right, like MS-DOS commands.
Exactly. But the real value was eventually in scripting, automation, and systemization. We treated a user interface feature of the chat box as if it were a complete software deployment platform.
Oh, wow. Yeah.
And it isn't.
Mm.
Prompt engineering, as it was sold to the public, was essentially the manual data entry of the AI era.
But let me push back on that, or at least pause you there, because the pushback I constantly get from founders is, well, but the models are getting smarter.
Right, the scaling laws argument.
Yeah. The narrative is that these massive frontier models are doing the heavy lifting now. So if the AI is a supposed genius, why do we need heavy system architecture? Shouldn't a smarter model just figure out what we want from a basic prompt?
Well, the genius analogy is interesting, but it actually highlights the exact problem we're facing.
How so?
A genius without boundaries, without context, and without a strict framework is a massive liability. Imagine you hire the smartest data analyst in the world,
Okay.
but you don't give them a desk. You don't give them a secure login to the database. You don't give them a clear reporting structure. And you don't give them strict legal rules about what data they are allowed to expose.
They'd just be wandering around the building causing chaos.
Exactly. Their raw intelligence is completely useless to the enterprise, and frankly, they are incredibly dangerous. The model's increasing intelligence doesn't reduce the need for architecture, it dramatically increases the stakes of the architecture.
Oh, that makes a lot of sense.
The smarter the model, the more complex the external tasks we are tempted to delegate to it, and therefore, the more robust the guardrails must be.
So going back to the ship analogy, it's like trying to steer a massive ocean liner by standing on the deck and shouting suggestions at the captain through a megaphone.
Yeah, pretty much.
Sure, a captain is a maritime genius, and maybe he hears your prompt, and maybe he turns the wheel a bit, but you aren't actually navigating. You don't have a radar system feeding telemetry to the bridge.
Right.
You don't know the depth of the water. You don't have automated stabilizers. You are just yelling adjectives into the wind and hoping the ship avoids the iceberg.
It's actually worse than that, if you can believe it. It's like shouting into a megaphone. When the captain only speaks French, the wind is blowing at 40 knots and the radar's completely broken.
Wow.
Real engineering is building the digital navigation system that connects the radar data directly to the helm, bypassing the megaphone entirely. Generating a clever output from a single prompt in a vacuum is easy.
Right, anyone can do it.
Exactly. A language model is a highly complex, probabilistic system. When you are just prompting it in a standalone interface, you are interacting with it in a stateless, isolated vacuum. But real software engineering requires systems that behave reliably across thousands of varied, messy, concurrent interactions.
A system has to handle edge cases. It has to handle malicious inputs, right? It has to handle network timeouts and database locks.
Precisely. A prompt engineer writes a clever instruction. A systems architect builds a state machine that gracefully handles the inevitable failure of that instruction.
Man, that is such a sharp distinction.
And the tragedy here, from a labor market perspective, is what happens to the thousands of people who branded themselves strictly as prompt engineers.
Yeah, what does happen to them?
The market is absolutely flooded with people who know how to summarize a PDF in a chat window. The supply of that skill has gone to infinity. But the market is critically, desperately short of software engineers who can actually build the underlying systems.
Which leads us directly into what I think is the most dangerous phenomenon in the tech industry right now, because if prompting is so wildly insufficient, why does it keep fooling smart executives?
Ah, yes.
Why do I keep seeing companies raise seed rounds based on a clever prompt? Let's talk about the demo trap.
The demo trap.
Ugh.
It is the most pervasive anti-pattern in the software industry today. I see it every single week.
Walk us through it.
It follows a very predictable sequence. An internal team is tasked with implementing AI to streamline a process. So they build a proof of concept.
A POSI.
Right. They use a standard chat interface or a very basic API script wrapped in a slick front end. They test it with a few carefully selected, perfectly formatted inputs.
Ah, the golden path.
Exactly. The happy path, where the user asks the exact question the developer anticipated in the exact format they expected, and the database responds in under 50 milliseconds. And it performs beautifully in this highly controlled sandbox environment.
So they take this flawless, orchestrated demo to the executive team.
Yes. And the business case is made. The ROI looks incredible on a spreadsheet. The funding is approved. The team pops the champagne.
And
then the project completely stalls.
Mm.
It dies a slow, agonizing death somewhere between the demo and production.
Why?
Because the team suddenly realizes that an AI system that answers questions well in a controlled demo is an entirely different species from an AI system that has to survive in the wild.
I have to rant about this for a second because this is my daily reality. I am so unbelievably cynical about slide deck culture and demo culture.
Oh, sure.
In a demo, you control the weather, you control the
Yeah.
lighting, you control the exact sequence of events. It is a magic show. You get the funding, and then reality hits you like a freight train because you don't have actual engineering discipline.
You really don't.
The VC landscape is littered with the corpses of startups that had an incredible 3-minute demo video, but literally zero capacity to handle concurrent user load, API rate limits, or edge case failure.
It is the massive gap between a toy and a tool. The realities of production that demo builders ignore are vast.
Give me an example.
Well, for instance, an enterprise system has to integrate with legacy databases that are incredibly messy. It has to maintain context across a long, asynchronous service interaction.
What does that mean in practice?
If a user starts a workflow, pauses it, and comes back 3 days later, the system must rehydrate the exact state of that interaction. It has to know how to escalate appropriately to a human when it reaches its confidence limits without dropping the context.
And there's a crucial detail here that we really need to emphasize from the source material: auditability. Logging every single decision for compliance.
Yes, absolutely critical.
Because in a demo, nobody cares why the AI said what it said. It just looks cool. But in enterprise software, particularly in regulated industries like finance or healthcare, if your system makes a decision, you must be able to prove chronologically what data the model had at the exact millisecond it made that decision.
Exactly.
If you are just relying on prompt engineering and a stateless API call, you have no telemetry. You have no audit trail. Which brings us to the ultimate killer of superficial prompts.
Yeah.
The absolute brick wall that these demo projects hit.
What is it?
Data distribution shift. I want to spend some real time on this concept because it is the fundamental reason why prompt engineering fails at scale, and it's something that non-engineers almost never anticipate.
I hear data distribution shift thrown around in boardrooms a lot, usually as a convenient excuse for why a project is delayed. Mechanically, what are we actually talking about here? Because to a business executive, data is just data.
Think about it this way. When you build your demo, you optimize your prompt based on the data you currently have in front of you.
Okay.
Let's say you are building an AI system that processes incoming technical error logs from your servers and categorizes them to alert the right engineering team. You write a brilliant prompt that perfectly parses the logs you are seeing in January.
Sounds solid so far.
The prompt expects the server name to be in brackets, the error code to be a 3-digit number, and the timestamp to be at the very end. It works perfectly.
Right.
But software is not static. It is a living, breathing ecosystem. 6 months from now, in July, your cloud provider pushes an update to their logging infrastructure.
Uh-oh.
Now, the server name isn't in brackets anymore. It's separated by a colon. And they added a new hexadecimal identifier in the middle of the log.
So what happens?
Well, a human engineer wouldn't even blink at this. They would instantly recognize it's the same basic information, just formatted slightly differently. But to your highly optimized brittle prompt, the underlying distribution of the data has fundamentally shifted.
The format mutated.
Exactly. The format mutated. The prompt that was perfect in January now completely breaks. It starts hallucinating. It starts categorizing critical database failures as low-priority UI bugs because it's looking for brackets that no longer exist.
Wow. And because you built a toy instead of a tool, the entire system comes crashing down over a colon.
Over colon. A prompt engineer's solution to this is to go back, panic, and manually tweak the prompt again to account for the new format.
And then it breaks again when another vendor updates their API.
It's an endless reactive game of whack-a-mole. A systems architect, however, anticipates data distribution shift from day one.
How?
They don't just rely on a brittle prompt reading raw logs. They build validation layers. They build a system that parses the log into a structured schema before it even reaches the AI.
Oh, I see.
They build monitors that detect when the model's confidence scores are dropping, which is a key indicator of a distribution shift. When the scores drop, the architecture automatically flags the anomalous data and routes it to a secondary, more specialized system or directly to a human for review.
So the architecture catches the shift and adapts while the prompt just breaks silently.
Precisely.
If you're sitting in a boardroom right now, or if you're the lead on a massive AI integration, you have to ask yourself, are we stuck in this exact bottleneck?
You really do.
Did your team have a massive celebration over a successful pilot 6 months ago, and now everyone is quietly avoiding eye contact in the weekly syncs because you have no idea how to actually deploy it without breaking your existing systems?
It's a very uncomfortable weekly sync.
It is, because if so, you are currently suffocating in the demo trap.
And climbing out of that trap requires a completely different educational foundation. You simply cannot prompt your way out of an architecture deficit. You need to learn the primitives of system design.
Which perfectly transitions us to the core of this entire deep dive, because if prompting isn't enough, and if the demo trap is destroying billions of dollars of enterprise value, how do you cross this massive chasm between a cute demo and a resilient production system?
It's the multi-billion-dollar question.
Where do you even go to learn how to do that? The answer is you look at what the pioneers are quietly studying. And this leads us to what is arguably the best-kept secret in AI education right now.
We are talking about Anthropic's Skilljar Academy.
Let's get into it.
The URL is anthropic.skilljar.com. And I want to be incredibly clear about what this is. If you work in software, if you build systems, or if you lead an organization trying to deploy AI beyond a sandbox, this is the most underutilized, highly critical resource in the field right now.
Here's where it gets really interesting. It is entirely free.
Yep, completely free.
It only requires an email address. And it's not just a couple of marketing blog posts or a high-level white paper. It is 18 full courses.
18.
Structured learning paths, quizzes, official certificates. It is a highly rigorous, incredibly dense technical curriculum hiding in plain sight. I mean, the vast majority of the industry has never even heard of this platform.
It's shocking, really.
Everyone is out there buying $500 prompt masterclass courses from self-proclaimed gurus on LinkedIn who were selling crypto advice 2 years ago.
Don't remind me.
Meanwhile, the actual engineers who built the Claude Frontier models have published the literal architectural blueprint for enterprise deployment for free. It's maddening, but it's also a massive, massive opportunity for anyone willing to do the work.
Let's look at what is actually in this catalog, because the breadth of it reflects the real complexity of enterprise AI. It starts with the absolute foundations. There is a course called Claude 101, which is designed for onboarding teams and moving them past casual, unstructured chat usage into structured, repeatable workflows.
Right, getting everyone in the organization speaking the same technical language before you start writing any actual code.
Exactly. Then there's a fascinating inclusion: AI fluency, framework and foundations. This covers the conceptual foundation for working with AI systems effectively, ethically, and safely. But what's notable here is that they have tailored companion versions of this course specifically for educators, students, nonprofits, and small businesses.
Wow, that's specific.
It is unusually thoughtful curriculum design for a highly technical infrastructure company. It shows they fundamentally understand that AI deployment isn't a monolith. It requires entirely different structural approaches depending on the operational domain.
But I have to put my cynical VC hat back on for a second.
Go for it.
If this curriculum is so incredibly valuable, if it contains the literal blueprints for enterprise AI architecture that companies are desperate for, why is Anthropic giving it away for free? What is the catch? In the tech world, if you aren't paying for the product, you are the product. So what is their strategic angle here?
Their angle is purely based on infrastructural economics. Think of it like a company that manufactures revolutionary high-speed microprocessors. Let's look at NVIDIA and CUDA, for example.
Okay, classic example.
The raw processors, the silicon, are completely useless if there are no motherboard manufacturers who know how to wire them up, and crucially, no software developers who know how to compile code to run on them.
Ah, I see where this is going.
Anthropic's bottleneck is not the reasoning capability of their Claude models. Their bottleneck is the lack of software developers who know how to deploy those models safely and predictably into highly complex production environments.
So they need a market of sophisticated practitioners to consume their compute.
Precisely. If a massive enterprise tries to deploy Claude using basic prompt engineering, they will inevitably fall into the demo trap. The project will fail, the executives will blame the AI, and Anthropic loses a potential multi-million-dollar enterprise API contract.
Oh, wow.
Anthropic needs software engineers to understand deep architecture so that those engineers build successful, high-volume systems that consume millions of API calls reliably. They're giving away the education for free because the education creates the ecosystem that runs on their infrastructure.
That is brilliant.
It really is.
Yeah.
They're trying to elevate the entire industry's baseline engineering competence because their core business model depends entirely on it.
That makes perfect sense. It's like an oil company giving away free, highly detailed engineering courses on how to build high-performance combustion engines. You don't make money on the classroom instruction. You make money on the millions of gallons of fuel those engines are going to consume over the next decade. And right now, everyone is trying to run a high-performance engine by pouring gasoline directly onto the hood and lighting a match. Anthropic is stepping in and saying, please, let us teach you how a fuel injection system actually works.
Perfect analogy. And while those introductory framework courses are great for establishing a baseline, the true gold mine, the absolute core of this curriculum, and the reason we are analyzing this today, is the API track.
We'll dig into it.
This is where we leave the prompt engineers behind and enter the domain of the system's software architect.
Deep architectural primitive number 1.
Yes.
The flagship course here is called Building with the Claude API. Anthropic's curriculum makes it clear this is the course that matters most to anyone building production software. It is over 8 hours of intensive instruction.
8 full hours.
8 hours. You don't spend 8 hours learning how to say please to a chatbot. So what are the actual mechanics being taught in there?
It covers the full spectrum of programmatic interaction. We are moving from the GI to the IDE. We're talking about system prompt architecture, external tool use, and crucially, context window management.
Let's break down system prompt architecture first, because it's wildly misunderstood.
It really is. In a graphical user interface, you just type a question and get an answer. In an API environment, you define a deeply structured architecture before the user ever interacts with the system. You define the model's precise role, its strict operational constraints, and its behavioral boundaries.
So it's not a chat anymore.
No, not at all. And you define them in a way that holds firm across diverse, unpredictable inputs.
Meaning it survives the messy real-world data distribution shifts we talked about earlier.
Yes. You aren't just saying you are a helpful corporate assistant. You are architecting a highly constrained state machine.
Give us an example of what that looks like in code.
You are programming strict instructions like, you are a routing node in a microservices architecture. Your only allowed outputs are valid JSON objects conforming to this exact schema. If the input data is missing the required customer ID field, you must instantly trigger error code 400. You are strictly forbidden from answering conversational queries, generating code, or acknowledging greetings.
Let's ground that JSON schema concept for a second, because that's a massive shift from how most people view AI. Think of JSON as a super strict digital filing cabinet format.
Yep.
If the AI is supposed to output a customer's name and age for the database, and instead it replies, sure thing, boss, here is the JSON you requested, name John, age 30, it completely breaks the software pipeline.
Instantly breaks it.
The database doesn't understand sure thing, boss. It only understands the strict brackets of the JSON format. System prompt architecture is about stripping the chat out of the chatbot. You are hard-coding constraints so that the probabilistic AI acts as close to a deterministic, reliable software component as mathematically possible.
That is the exact goal. And once you have constrained the output, you have to manage the input. This brings us to the discipline of context window management, which is perhaps the most critical engineering skill in the API track.
Explain context windows for us.
The context window is the total amount of text, code, or data the model can hold in its active memory at any given computational moment. Currently, models have massive context windows, hundreds of thousands of tokens.
Right, Claude's is huge.
But simply stuffing everything into that window is a catastrophic architectural mistake.
I compare poor context management to dumping a massive, rusted filing cabinet containing 10,000 completely unorganized papers onto the desk of a brilliant human analyst and just yelling, figure it out.
That's exactly what it feels like to the system.
The analyst is incredibly smart, sure, but they are going to spend 90% of their time just sorting through the garbage. They'll probably miss the crucial detail hidden on page 8,000. They will take hours to give you an answer, and they will be exhausted.
It's a very accurate comparison. Stuffing the context window is the lazy approach, and it is a massive failure point in enterprise systems for 3 specific reasons.
Let's hear them.
First, it massively increases latency. The model has to physically compute attention over all that garbage data, turning a half-second response into a 10-second response, which is completely unacceptable in a live software environment.
Nobody is going to wait 10 seconds for a button click.
Right. Second, it exponentially increases compute costs. You are paying for every single token you process. Dumping irrelevant data literally burns money.
Fast.
Very fast. Third, and most dangerously, it degrades the model's reasoning capabilities. There is a well-documented phenomenon called lost in the middle, where a model completely forgets or ignores critical information buried in the center of a massive context payload.
So what does good architecture actually look like here? How do you prevent the data dump?
Good architecture is having a precise algorithmic routing system that only feeds that brilliant analyst the exact 3 sheets of paper they need at the exact millisecond they need them, and absolutely nothing else.
Wow.
The Anthropic API course dedicates significant time to this exact discipline. It's essentially advanced memory management for AI. How do you decide what information the model actually needs for a specific query? How do you chunk and embed your massive enterprise databases so you can retrieve only the semantically relevant context?
Let's break down chunking and embedding, because that's where the real magic happens.
Sure. Imagine your company has a 10,000-page technical manual.
Yeah.
You can't just feed the whole manual to the AI every time a user asks a question.
Right, that would be insane.
So you chunk the manual, you programmatically break it down into thousands of individual paragraphs. Then you embed those paragraphs.
What does embedding actually do?
Embedding is a process where a separate, smaller AI model reads each paragraph and converts its semantic meaning into a massive list of numbers, a high-dimensional vector.
I always visualize embeddings as a massive 3D map. But instead of mapping physical cities, you are mapping concepts.
That's a great way to look at it.
So the concept of database error 500 is placed right next to server timeout on the map, but it's miles away from employee vacation policy. When you embed a database, you're just assigning precise conceptual GPS coordinates to every paragraph your company has ever written.
Exactly. So when a user asks a question, you convert their question into a vector. You find its GPS coordinates on that map. Then you use a high-speed vector database to find the 3 paragraphs that are geographically closest to the user's question.
The nearest neighbors.
Yes. You retrieve only those 3 paragraphs, and you feed only those into the AI's context window. That is context management. It is fast, it is cheap, and it prevents the lost-in-the-middle degradation.
If we connect this to the bigger picture, it's incredible. Back in the day, systems software engineers had to be utterly obsessed with managing RAM. You couldn't just load an entire massive application into memory. You had to carefully swap data in and out of active memory as needed.
Yep, paging.
Now, we are doing the exact same thing, but instead of managing RAM blocks, we have to meticulously manage the AI's active context window.
And this 8-hour API course is the exact dividing line separating the industry. On one side, you have the practitioners who build fragile demos by stuffing a prompt. On the other side, you have the architects who build real, scalable products by engineering the context pipeline and managing state.
It's a totally different game.
The foundational knowledge in this single course is what the labor market is desperately bleeding for right now.
But architecture isn't just about managing the context, right? It's not just about controlling what the model knows or remembers. It's about making the model actually do things in the real world.
Absolutely.
A model that just sits there analyzing data in a box is a glorified calculator. We need these systems to execute actions. We need them to update the CRM, query the inventory database, or trigger a deployment pipeline.
And that brings us to deep architectural primitive number 2, which honestly changes the entire paradigm of how software interacts.
Lay it on us.
We are talking about the Model Context Protocol, or NCP. The Academy features a course specifically called Introduction to Model Context Protocol, as well as advanced MCP tracks. This is where we definitively sever the concept of AI from the basic chat interface.
So break down MCP for us, because Anthropic describes it as treating prompts as primitives and securely connecting Claude to external services and data sources. What is the mechanical reality of that?
To understand why MCP is so revolutionary, you have to understand how software usually communicates.
Right.
We have standardized protocols like HTTP or REST APIs.
Right.
These protocols allow entirely different systems, say a server in Tokyo and a smartphone in New York, to exchange data seamlessly because they agree on the exact format and rules of the communication.
They speak the same language.
Yes. Until very recently, AI models completely lacked a standardized, secure protocol for connecting to external data.
Right. Every time a developer wanted an AI agent to read from a specific internal database or call an external weather API, they had to write custom, incredibly fragile middleware. It was a completely bespoke, duct-taped bridge every single time.
And that bespoke middleware is an absolute nightmare to maintain.
I can imagine.
The Model Context Protocol is an open standard introduced by Anthropic that standardizes exactly how AI models connect to data sources and tools. It turns the prompt into a foundational infrastructure primitive.
So no more hacky Python scripts.
Exactly. Instead of manually pasting data into a prompt or writing a hacky script to glue an API to a model, MCP allows the model to act as a secure client. The model queries an MCP server, which acts as a standardized, tightly controlled gateway to your company's internal tools, your code repositories, your Slack channels, your SQL databases, your internal wikis.
Oh, that's huge.
Think of it like USB, but for AI integration. Before USB, every peripheral had a different proprietary plug. You had parallel ports, serial ports.
Oh man, the bad old days.
Yeah. USB standardized the interface. MCP standardizes how AI connects to the enterprise.
This is massive, because as a venture catalyst, when I talk to enterprise CIOs, the thing that keeps them awake at 3.0 isn't that the AI is going to write a bad poem or hallucinate a historical fact.
No, they don't care about that.
They lose sleep over AI making unpredictable, unauthorized external calls. The absolute nightmare scenario for a CIO is an AI agent hallucinating a database command and accidentally executing a drop table command that deletes all customer records.
A literal catastrophe.
Or an AI securely authorized to read a database, but then it scrapes highly sensitive HR salary data and leaks it in a customer service chat because the integration was just a sloppy script with no boundaries.
And that is exactly the anxiety that MCP is designed to solve. It is built entirely on the concept of controlled, predictable, and auditable interaction.
How does it enforce that?
MCP enforces strict boundaries at the protocol level. The AI never gets raw, unrestricted access to the database. It gets access to very specific, predefined tools exposed through the MCP server. And the host system, your company's infrastructure, maintains complete, absolute control over the authorization, the rate limits, and the execution of those tools. It allows the AI to touch real company data without risking a catastrophic breach. It brings enterprise-grade security and standardization to AI tool use.
So we're talking about an architecture where the AI can securely reach out, pull data from a live production database, synthesize it, and then securely push an update to a billing system, all using standardized transport mechanisms where every single step is logged and authenticated.
Yes, and the Academy courses teach exactly how to architect this gateway. Furthermore, the catalog includes courses like Claude Code 101 and Claude Code in Action.
What do those cover?
These courses show how to integrate the model directly into the actual coding practice and software development workflows. This fundamentally changes how engineers build software. We aren't just using AI to generate boilerplate code snippets in an editor.
Right.
We are building systems where the AI is deeply integrated into the CI/CD pipeline, the testing frameworks, and the infrastructure deployment.
It is the difference between asking an AI to write a Python script for you versus building an AI system that constantly monitors your live server logs, identifies a latency anomaly, securely queries your code repository using MCP to find the specific commit that caused the bug, and then drafts a patch and opens a pull request for a human engineer to review.
Yes, exactly.
One is a cool parlor trick. The other is a multi-million-dollar enterprise capability that fundamentally alters the speed of development.
Which perfectly sets up the final evolution of this architecture.
Let's go.
Once you have the model safely talking to your systems via MCP, and once you have mastered context management to prevent hallucinations, the architecture fundamentally evolves again. It stops being a single, monolithic entity trying to answer questions.
Now, what does it become?
It becomes a decentralized, automated workforce.
Deep architectural primitive number 3, the 2025 reality of subagents and agent skills. Anthropic's curriculum notes that these are newer additions to the Academy catalog: Introduction to Subagents and Introduction to Agent Skills. It also specifically calls out deployment courses for Amazon Bedrock and Google Cloud's Vertex AI.
This is where the field is definitively heading right now, and the curriculum is uncompromising on this point. If you are building at the enterprise level in 2025, you either already are moving toward multi-agent architectures, or you will be within the year.
Bold claim.
The monolithic AI call is dead. We are moving entirely to automated task delegation.
So what does this all mean? Let's use an analogy to make this concrete. In 2023, the entire industry was obsessed with building God models.
Right. The one prompt to rule them all.
A single, massive AI agent with a massive system prompt that you would just throw every possible task at. It's like having one single genius executive trying to run every single department in a massive corporation simultaneously.
The recipe for burnout.
They are trying to do the complex accounting, they're drafting the marketing copy, they are resolving HR disputes, they are managing logistics, and they are doing frontline customer support all at the exact same time. It doesn't matter how unbelievably smart that one person is, they are going to become overwhelmed.
They'll drop the ball.
They will mix up the context between the accounting and the marketing, their latency will skyrocket, and the entire corporate operation will grind to a halt.
Exactly. A monolithic prompt Trying to execute 10 different tools and maintain context across 5 different domains will suffer from severe degradation in reasoning quality. It will drop instructions. It will hallucinate connections between data points that don't exist. It is an architectural anti-pattern.
So a multi-agent architecture is like finally building an organized, rational corporate structure.
Yes, specialization.
Instead of one genius doing everything poorly, you build specialized, narrowly scoped AI agents that report to each other in a hierarchy. You have a triage agent whose only job, its entire programmed existence, is to read incoming data, classify it, and route it.
Just routing, nothing else.
You have a research agent whose only job is to use MCP to securely query the SQL database. You have an execution agent whose only job is to format the final JSON output. And you have an orchestrator agent acting as the manager, breaking down the user's complex request into subtasks and delegating them to the appropriate subagents.
That is the exact architectural pattern taught in these specific courses. It is about building reusable skill frameworks. You build a specialized skill like querying a specific legacy API, and you assign it to a subagent.
And that makes it more stable.
This makes the entire system infinitely more resilient. Think about the failure states. If a monolithic model fails to query an API, the entire system crashes and the user gets an error.
Which is awful for user experience.
But in a multi-agent architecture, if the research agent fails to find the data, it doesn't crash the system. It reports the failure state back to the orchestrator.
Oh, that's clever.
The orchestrator can then dynamically decide to try a different strategy, query a different agent, or elegantly escalate to a human while maintaining the entire context of the operation.
And the fact that the Academy explicitly includes deployment courses on Amazon Bedrock and Google Cloud's Vertex AI is the smoking gun here. It proves this isn't just theoretical sandbox play.
Absolutely. Bedrock and Vertex AI are the absolute heavyweights of enterprise cloud infrastructure. Banks, healthcare systems, logistics giants, they run their highly secure, mission-critical workloads on AWS and Google Cloud.
Right, they have data gravity.
Exactly. They are not going to move their petabytes of sensitive customer data to a new startup's platform just to use AI. By explicitly teaching how to deploy Claude within these specific, highly regulated cloud ecosystems, Anthropic is proving that this curriculum is about meeting enterprise infrastructure exactly where it already lives.
They're playing the long game.
You don't ask a Fortune 500 bank to migrate their data. You teach their engineers how to deploy multi-agent architectures securely within the AWS virtual private cloud they already control.
This is real software engineering. We are talking about CI/CD pipelines, identity and access management roles, virtual private clouds, load balancing, and secure enclaves. This is so far removed from the concept of prompt engineering that it honestly shouldn't even be in the same sentence.
It's an entirely different profession at this point.
We've laid out the curriculum. We've gone incredibly deep into the architectural primitives, context management, the model context protocol, and subagent delegation. Now, we need to talk about the cold, hard reality for the market and what this actually means for you.
The payoff.
Let's look at what Borion AI points out regarding the value of this architecture and the ultimate market ultimatum.
The documentation highlights the explicit value of the official Anthropic certificates you get upon completing these courses. And it references a specific philosophy from an entity called Borion AI, which builds these systems.
What's their stance?
Their stance is striking. They state that the architecture patterns covered in Anthropic's API curriculum are not academic exercises or theoretical best practices. They are the exact, uncompromising infrastructure primitives used to build every production system deployed for large enterprises.
They don't mince words.
They draw a hard line. If your organization is ready to move from AI experimentation to AI delivery, we should talk.
Let's focus on the ROI of all of this because that's where the rubber meets the road. Yes, having an official certificate with Anthropic's name on it carries massive weight.
Sure does.
If you are a developer in a hiring pipeline, or if you are a consulting firm in a high-stakes enterprise procurement conversation trying to win a 7-figure contract, being able to mathematically prove you hold credentials from the actual creators of the frontier model is a massive differentiator.
It's a huge step of approval.
But as a VC, I look at the certificate as just the secondary benefit. The paper is nice for HR, but the primary benefit is possessing the actual hard mechanical knowledge that the market is desperately bleeding for.
Because that knowledge is the literal difference between an organization endlessly experimenting and an organization actually delivering value.
Exactly.
The Borion AI stance perfectly encapsulates the divide in the industry right now. Experimentation is building the fragile demo. It's tweaking prompts in a sandbox and celebrating a localized success.
Delivery is something else entirely.
Delivery is deploying the resilient, multi-agent, MCP-enabled architecture that survives data distribution shifts and handles 10,000 concurrent requests without dropping a database table. These are the uncompromising realities of enterprise delivery.
You cannot fake your way through an AWS Bedrock enterprise deployment with clever adjectives. You either know how to architect the primitives or your system crashes.
That's the bottom line.
So if you are sitting in a boardroom or managing an engineering team, here is the reality of the situation. The time investment required to learn this is incredibly straightforward. It's self-paced. It's entirely free.
No excuses.
You just need an email address, an internet connection, and the willingness to actually sit down and learn the deep mechanics of system design. The question isn't whether this knowledge matters. If you've been listening to this, you know it clearly does. This is the blueprint for the next decade of software.
It really is.
The only question you have to ask yourself today is whether you build this knowledge before or after the organizations and the engineers competing with you do.
Because the window where just knowing how to use an AI chatbot was considered a competitive advantage has officially closed. The organizations that survive the next 2 years will be the ones that stop obsessing over the magical, probabilistic outputs of the raw models and start obsessing over the invisible, deterministic engineering architecture that surrounds them.
Let's quickly summarize the ground we've covered today. We started by burying the hype. We took a shovel to the myth of the prompt engineer and recognized that shouting into a broken megaphone is not navigating the ship.
We dissected the treacherous demo trap.
Right, exposing exactly why so many highly funded projects choke on data distribution shifts, lack of audit trails, and scaling failures. And then we uncovered the best-kept secret in the industry, Anthropic's free Skill Jar Academy.
We walked through the deep architectural primitives taught in that 18-course curriculum.
We examined context management, the precise, vector-based art of routing exactly what the model needs rather than lazy data dumping.
We explored the modern context protocol, turning prompts into secure, standardized infrastructure primitives that connect AI to the real world without compromising enterprise security.
And we mapped out the 2025 reality of subagents' decentralized, automated task delegation, operating securely inside massive cloud environments like AWS Bedrock and Google Cloud.
It's a massive shift.
So the final takeaway is simple. If you aren't architecting, you are just playing in a sandbox. Head over to anthropic.skilljar.com, stop prompting, and start building actual software.
And as we close, this raises an important question that really builds on everything we've uncovered today.
Lay it on us.
As these frontier AI models themselves become increasingly commoditized, as the raw cognitive engines from different providers begin to look more and more similar in their base reasoning capabilities, will the ultimate defensible moat for a business simply be the quality of their invisible engineering architecture?
Oh, that's a fascinating thought, because if everyone has access to the exact same genius intellect via an API, the only thing that separates you from your competitor is how well you built the desk, the database, and the workflows for that genius.
Exactly. 10 years from now, will we look back at prompt engineering the exact same way we look at people who used to memorize manual dial-up internet commands or MS-DOS syntax?
Almost certainly.
A fleeting, slightly ridiculous, obsolete quirk of history that existed for a brief moment before the real, silent infrastructure was built to handle the complexity for us. I strongly suspect we will.
A fleeting quirk before the real suspension bridge was built. Because in the end, it's never about the magic words you whisper to the cables. It is always about the physics. Keep building resilient systems, not just generating isolated outputs.